Morning, guys. Really sorry this is late. Kind of couldn't really figure out what the best way to deliver this was, so had it done yesterday, but it just didn't work. So I'm going to try it this way. Um, so yeah, we had started working on the periodic table. We talked about the groups, the periods. Dmitry Mendeleev, who organised the periodic table in the way we know it today. We then went on and we took each of the groups and we drew a Bohr model for each of the groups, and we discovered that the outer so if you're in group one, you will have one electron in your outer shell. If you are in group two, you will have two electrons in your outer shell, and so on. We then started talking about the kind of four named groups, which were group 1, 2, 7, and 8. And then we went into a little more detail with group 1, which are the alkali metals. So here they are here. The alkali metals all have one electron in their outer shell. So that makes sense. Group 1, one electron. We talked about the fact that what all of the atoms are striving for is having a full outer shell. So given these have just the one in their outer shell, what they want to do is get rid of that. So then they drop back to their kind of previous one. So we looked at the reactivity of lithium, sodium, and potassium. We said because they've one electron in their outer shell, they want to get rid of it quite readily, which means they're kind of happy to react with things like air, water, and then obviously the group 7 elements they're very happy to react with. So the reactions of alkali metals with water. So we did this. I put a small bit of lithium into water, and so it turns into what's called lithium hydroxide, and then hydrogen. If you remember, there was like smoke coming off. There was like a gas been released when we were watching that experiment. So that was hydrogen gas. Sodium and water is sodium hydroxide, and then the hydrogen was produced as well. And then we also did potassium and water, which would be potassium hydroxide, and again with hydrogen gas being given off. Okay, so when alkali metals react with water, you get hydroxides, and you also get hydrogen gas being emitted. The reaction of the alkali metals with air, we spoke about this. We said that when I took it out of the oil, it was quite dull. When I cut it, so I was exposing a fresh bit, it was really shiny. It looked like what you'd expect a metal to look like. And then the longer you leave that exposed to the air, it reacts with the air and it goes dull. So when lithium reacts with oxygen, so it's the oxygen in the air that it's reacting with, lithium plus oxygen, you get an oxide. Okay, so when it reacts with water, you get an hydroxide. When it reacts with air, you get an oxide. So lithium and oxygen is lithium oxide. Sodium oxygen is sodium oxide. Okay, so with water, hydroxide. With air, or specifically oxygen, it's oxide. All right, and it kind of makes sense. The hydro part here kind of relating to water, and then the ox part here relating to oxygen. Okay, so group 2 elements then. So they're called, we just got onto these, they're called the alkaline earth metals. Elements in this group, so you can look down the group 2 is beryllium, magnesium, calcium. The fact that they're group 2, and we went through all this, means they have 2 electrons in their outer shell. They're not going to be as reactive as the group 1 elements, because it's not as easy to lose 2 as it is to lose 1, but they're still quite reactive. They would engage in chemical reactions. The third named group then is group 7. So we know that in group 7 we're going to have 7 electrons in the outer shell. In this case, rather than lose an electron, which is what the group 1s are trying to do, the group 7s are actually trying to gain an electron. So that's why the group 1s and the group 7s are very compatible. Put them together and they will react, because the group 1s will give the electron away and the group 7s are happy to take that electron, and that would leave both of them with a full outer shell. The group 8s then, which are the noble gases. So they have 8 electrons in their outer shell, and as we know, 8 electrons is a full shell, unless it's the first shell, because the full one there is 2. Okay, so remember that in our first we can fill 2, the one after that is 8, and then after that is 8, and then so on. Okay, it's 2, 8, 8, 8, 8, 8. So if it's the first shell, a full shell is 2, and anything after that, a full shell is 8. So noble gases have full outer shells. Okay, so that makes them quite unreactive and very stable. All right, and then again, you can go to group 8 and have a look at some of them, but helium, neon, argon are some of the examples. We talked about ions. So when an atom loses or gains an electron, it becomes a charged particle and it's called an ion. So we were saying in group 1, what do they want to do? They want to lose 1 electron. If they lose an electron, they lose negativity. So if you lose, if you lose an electron, you are losing negativity, which means you become positive. Okay, so it's a positive ion when it loses an electron. So there's group 1 there. They have 1 electron in their outer shell, which they want to lose, so they form a positive ion. They're only losing 1 electron, so that's why it's +1. So a sodium that has succeeded in its life goal of losing its electron becomes Na+1. Group 2 then, they have 2 electrons to lose, so they will lose 2 electrons, and again, because they're losing negativity, they'll become positive, but because they're losing 2, they're not a +1, they're actually a +2. Group 6, so group 6 and group 2 are quite compatible because group 2 wants to lose 2 and group 6 wants to gain 2. They don't have a specific name, they're just called nonmetals here. They have 6 electrons in their outer shell because it's group 6. So if they gain 2, they will have an outer shell. Now, if they're gaining electrons, that means they're getting some extra negativity. So that makes them negative. Okay, so they become a negative ion. And in the case of group 6, they're losing, or they're going to gain 2 electrons, so it becomes a -2. The halogens, as we said, they pair up nicely with group 1. They want to gain 1 electron, so they're gaining 1 extra negative charge, so they become a negative ion, and it'd be a -1. Okay, so that's ions. You need to know the definition here. This is important. And obviously this idea of when you lose an electron, you're losing negativity, so you become positive, and then obviously on the flip side, if you're gaining an electron. Right, the next thing then is how are chemical bonds formed. So there's a couple of different types of bonding. So a compound forms when 2 different elements chemically combine. We learned that in the last chapter, so you should have an idea of that already. So I suppose now we're talking about why they combine. Why does that even happen? So why are compounds formed? And the reason they're formed is because of the atom's life goal to have a full outer shell. So that's why different atoms come together and combine, because they're more stable when they're in that bond and they have full outer shells. Okay, when it says they're in a compound, the atoms are joined by chemical bonds. Okay, so we make these bonds. Remember we talked about the difference between like compounds and mixtures, and with mixtures they're not chemically combined. With mixtures they can quite easily be separated, whereas when you bring a compound or a molecule together, they are chemically combined, so not easily separated. So they make chemically combined means they're going to bond together. So when they bond, there are kind of 2 ways to do it, but I suppose you could split it into 3. They're either going to give away electrons, they're going to take electrons, and they sort of fall under the same heading, I suppose. And then the other thing they could do is share electrons. So basically, they're going to give away or take electrons, or they're going to share. Okay, and they have 2 names. So the giving away and taking of electrons is called ionic bonding. And when 2 atoms share electrons, it's called covalent bonding. Okay, so you can see it here. Ionic bonding produces a compound that is formed from a metal and a non-metal and is made up of ions. This occurs when one atom loses electrons and the other atom gains electrons. Okay, so a lot of information there. So ionic bonding happens on this concept here, where one atom wants to lose its electrons, and there's another atom that wants to take these electrons. Okay, the reaction you can see here, an ionic bond happens between a metal and a non-metal. So a good example here is sodium and chlorine. So sodium is a group 1 metal. Now, they haven't drawn a proper Bohr diagram here. All they're showing you is the outer shell. And you can see in the outer shell, because it's group 1, we've just got the 1 electron. Here we have chlorine, and chlorine is a group 7 halogen. So that means it has 7 electrons in the outer shell. So sodium and chlorine bond very nicely together. And essentially what they do is sodium gives this atom here over here to chlorine. So it's losing that electron. So it's losing negativity. So it's going to become a sodium plus 1. It's going to give that away. And then chlorine is going to take that and become a Cl minus 1. And then they are bonded together in an ionic bond. Okay, so by giving away the electron and becoming a positive ion, and the chlorine taking the electron and becoming a negative ion, they are bonded in an ionic bond. Okay, now the other one, a covalent bond. So this produces a compound again. They all produce, that's the whole point of the bonding, to produce a compound. It's formed from non-metals, okay, in which each atom shares. That's the big thing about covalent bonding. It's sharing of electrons. So neither atom wants to donate, as they both need electrons to fill their full shell. So this, I suppose it depends. It will generally happen between non-metals. It will always happen between non-metals. So here we have an example of hydrogen and chlorine. So they're both non-metals. They're both liquids and gases. And I suppose it's when you don't have that obvious, like group 1, group 7, lose an electron, gain an electron kind of thing. This is where they're just going to share it. So if you look between hydrogen and chlorine here, so hydrogen has 1 electron in its outer shell. So that's it there. Okay, that's all hydrogen has, just the 1 electron. It's not even in its outer shell, it's all it has. So if hydrogen can get 1 more electron, it's got a full outer shell. Chlorine then, we said already, is in group 7, so it's got 7 electrons in its outer shell, so it needs that 1. Okay, and the way they do it is they share the electron. So hydrogen has use of this electron, and it also uses one of chlorine's electrons. So now it's got its full outer shell of 2. And chlorine uses the 7 it has by itself, and it's going to share use of this one. And then it's got 8 in its outer shell. So that idea of sharing of electrons is a covalent bond. And that's in the compound HCl. Did I say that up here? The compound formed here is NaCl. Okay, so just 2 different ways of bonding. Remembering that ionic bonding is between a metal and a non-metal, whereas covalent bonding is between non-metals. Okay. Chemical formulas, we've done this already. Every compound has a formula. It tells you the type and number of atoms present in the compound. So there's 2 examples here, CH4 and H2O. So the letters tell you the type of atom. So we did that already. The C would represent carbon, the H would represent hydrogen, the H here represents hydrogen, and the O represents oxygen. And then the numbers tell you how many of the atoms there are. So here we've got 1 carbon atom and 4 hydrogens. Here we've got 2 hydrogens and 1 oxygen. Okay, so we've kind of gone through all that already. And combining of metals and non-metals. So this is more just around the wording. So when a metal and a non-metal combined, which we talked about we talked about above, metals and non-metals would combine in an ionic bond. And when the two of them, so here's your sodium from group 1 and your chlorine from group 7, when they combine, it becomes an ide. Okay, so the name of the metal comes first, the sodium, followed by the non-metal, which would be the chlorine, but you change its ending to ide. Okay, so that's when you're forming an ionic bond. Metal first, non-metal second, ending in ide. Okay, and then just talking here about kind of ratios and how much of each. Sodium is in group 1 of the periodic table. We know that. That means it needs to lose 1 electron. Chlorine is in group 7, so that means it needs to gain an electron. We've talked about all this. So the ratio of atoms in the compound sodium chloride is 1:1. Okay, so we need like 1 sodium pairs perfectly with 1 chlorine, and that works fine. So it's a 1:1 ratio. Okay, little bit more complicated when we're talking about non-metals and covalent bonds. So when you're combining non-metals here, we're talking about hydrogen and carbon here. So hydrogen is in group 1 of the periodic tables, which shows that it has 1 electron and it needs 1 more to have that. So if hydrogen's here, there it is, it has the 1, it has a missing 1 here. So this is what it needs to fill its outer shell. So we say it has a combining power of 1. Carbon is in group 4 of the periodic table, which means it has 4 electrons in its outer shell, so it requires 4 more, so it has a combining power of 4. Yeah? So, first thing is naming them. So when naming compounds formed... Sorry, let me just finish this bit. I don't know why I didn't include that. Anyway, so we said we carbon, and carbon has 1, 2, 3, 4, which means it's missing 1, 2, 3, 4. So when you're combining these two, hydrogen has a combining power of 1, carbon has 4. So you would need a hydrogen here, you would need another hydrogen here, you would need another hydrogen here, and you would need another hydrogen here. Yeah? So to make that compound, that covalent bond work, you would need 1 carbon, but you would need 4 hydrogens to make it work. Okay, so that's where the ratios change, as opposed to sodium chloride, which is literally just 1 sodium, 1 chlorine. Sorry, when you're doing it in a covalent bond, you have to look at how many would be required. So this hydrogen has a combining power of 1. The carbon has a combining power of 4. So you're going to need a hydrogen for every single one of these. So it changes the ratio. So 1 carbon is to 4 hydrogens. Okay, sorry, I should have included that in actual print. Last thing here then is just, I think this is the last thing, yeah, just naming, so combining metals, non-metals, and oxygens. So when you're naming compounds formed by combining a metal and non-metal and oxygen, metal first, non-metal second, so same as above, but now instead of ending in ide, it ends in ate. So potassium is your metal, phosphorus is your non-metal, and then we're going to add oxygen. So it becomes potassium, and instead of phosphorus, it's going to be phosphate. Here, sodium is the metal, carbon is the non-metal, and then because of the oxygen, it's carbonate. Okay, and that pretty much finishes off that chapter on the periodic table. So I have a document here with a bit of work that I want you to do, which is basically just a recap of that whole chapter. So again, apologies it's late, but have a look through this video, put notes into your copy please, just like you would if you were in class, and then do this work into your copies, photograph it, and attach your work to Schoology. I'm going to put the due date for this at the start of our class next Tuesday, so you have to submit it before that due date or you won't be able to submit it. Alright, thank you, talk to you soon, hope you're all well.